Imagine you want to build a treehouse for your kids. Would you just pick a random tree and start hammering away? No, of course not. You'd first examine the tree, checking its stability, size, and strength. That's precisely what geotechnical investigation does, but on a much larger and more complex scale. Hello everyone, and welcome back to Civil Mentors. In today's episode, we will take a closer look at geotechnical investigation. Join us as we explore the importance of this process, the methodologies involved, and the invaluable insights it offers for constructing strong and durable structures. So let's not waste any more time and dive right in. Geotechnical investigation, also known as ground or soil investigation, is a crucial step in the construction process. This systematic study involves examining the soil and rock beneath a construction site to determine their physical properties, composition, and characteristics. The investigation provides valuable insights to engineers, helping them design safe and efficient foundations, slopes, retaining walls, and other structures. Consider the construction of a high-rise building in an urban area. The soil conditions at the site may include soft clay layers, mixed with sand and rock at various depths. Without a proper geotechnical investigation, the foundation might not be designed to handle the building's weight or resist the forces generated during an earthquake. By conducting a thorough investigation, engineers can determine the most suitable foundation type for the structure to transfer its load to a more stable layer. Also suggest ground improvement techniques, such as soil compaction or grouting, to enhance the soil's strength and reduce settlement. A thorough geotechnical investigation is vital and for several reasons, which includes safety. Knowing the soil's properties helps engineers design foundations that can support the weight of the structure and resist natural hazards such as earthquakes, landslides, and soil liquefaction. Cost-effectiveness. By understanding the soil conditions, engineers can select the most suitable construction techniques and materials, which can save time and money in the long run. Environmental protection. Geotechnical investigation helps identify and mitigate potential environmental impacts, such as groundwater contamination or erosion. Legal compliance. In many jurisdictions, conducting a geotechnical investigation is a regulatory requirement to ensure that construction projects meet safety standards and environmental regulations. Geotechnical investigation involves several steps, which can vary based on the project's size and complexity. Here's a general overview of what those steps look like. Desk study. This preliminary research involves collecting existing data about the site, such as geological maps, aerial photographs, and historical records. This information helps engineers develop an initial understanding of the site's conditions and identify potential hazards. Site reconnaissance. In this phase, engineers visit the site to visually inspect the terrain, vegetation, surface water, and any signs of instability or distress. They also look for evidence of past construction, such as old foundations or utility lines. Field investigation. This is where the real fun begins. Engineers use various techniques to collect samples and gather data about the subsurface conditions. Laboratory testing. The collected samples are sent then to a laboratory where engineers perform various tests to determine the soil's physical and mechanical properties, such as grain size, moisture content, density, and shear strength. Data analysis and report. Based on the field and laboratory data, engineers analyze the site's geotechnical conditions and prepare a comprehensive report. This report includes information on soil stratigraphy, groundwater conditions, soil-bearing capacity, settlement estimates, and slope stability. It also provides recommendations for foundation design, excavation support, dewatering, and any necessary ground improvement techniques. As technology advances, so do the methods and tools used in geotechnical investigation. Some exciting developments in the field include remote sensing. Techniques like light detection and ranging or LiDAR, and satellite imagery provide high-resolution 3D data about the site's topography. This information is valuable for identifying potential hazards and designing access roads, drainage systems, and other necessary infrastructure. Geophysical methods. Non-invasive techniques like seismic refraction, ground-penetrating radar, and electrical resistivity imaging allow engineers to create detailed subsurface profiles without the need for extensive drilling or excavation. Machine learning and artificial intelligence. Advanced algorithms and data processing tools can help engineers analyze vast amounts of data, identify patterns and trends, and make more accurate predictions about the site's geotechnical behavior. This essential process plays a critical role in ensuring the safety, cost-effectiveness, and environmental sustainability of construction projects. By examining the soil and rock beneath our feet, engineers can design structures that stand the test of time and withstand the forces of nature. And that's all for today's episode. Thank you for joining us. If you enjoyed this video, be sure to give it a thumbs up. And don't forget to subscribe for more upcoming videos. Till then, peace out.